Now in this section we shall be dealing about the coordinate bonding. The other name for this type of bonding is also dative linkage bond, or it's a special type of covalent bond. We shall be dealing in the section that why we call such a bond as covalent bond, or why we call such a bond as dative linkage bond. So let's start firstly that what does coordinate bonding mean and how does it take place. Let's consider a molecule of NH3, that is ammonia. In the last section we have discussed that there are 5 electrons in the valence shell of nitrogen, out of which 3 are participating here in the bonding with hydrogen, and the 2 electrons will remain unbonded, whom we have called as lone pair. So this is the pair of electron in the valence shell of nitrogen, which will be called as lone pair. For more illustration, we can see that nitrogen has an atomic number of 7. Its configuration will be 1s2, 2s2, 2p3. Now the valence shell of nitrogen is 2s2, 2p3, and it's quite known to us that only the valence shell electrons participate in the bonding. Here, if we observe, then we find that the 2s orbital of nitrogen has got 2 electrons which are paired, and 2p orbitals, that is 2px, 2py and 2pz here. Here we have got 3 electrons in the p, so it will be distributed in the 3p orbitals in this way. Now when nitrogen undergoes bonding with 3 hydrogen atoms, its 3 unpaired electrons will be bonded to hydrogen. Means these 3 electrons will be utilized during bonding, and the next 2 electrons present in the 2s orbital of nitrogen will remain unshared. Only these 3 will be shared, these 2 will remain unshared, or we can say these 2 will remain unbonded during bonding. And these 2 electrons, which we are calling as lone pair, are basically the part of the 2s orbital of nitrogen. Now if we say that an electron deficient atom like H positive, if it approaches NH3, then here we are finding that when nitrogen is undergoing bonding with 3 hydrogen atom, then after that it will have a complete octet, because it has got 5 electrons, 3 plus 2 5, and 3 electrons will be shared by hydrogen, so total it will have 8 electrons. That means nitrogen in NH3 will have no tendency to undergo bonding, because its octet is already complete by the 3 hydrogen atoms, but it has got a pair of electrons which are unshared. Hence when H positive will approach NH3, 2 electrons belonging to nitrogen, that is the lone pair, will be shared by H positive, and this sharing of the pair of electron by an electron efficient atom to electron deficient will be called as a coordinate bond. So I would like to repeat that in case of ionic bonding we have discussed that the complete transfer of electron take place from the metal to the non-metal. In case of covalent bonding, we have the mutual sharing of electron, that means the bonding atoms mutually share electrons. But in case of coordinate bonding, an electron efficient atom, here we have got nitrogen whose octet is complete, and it has got 2 electrons in its valence shell which are unbonded, unshared. So these 2 electrons can be further shared by an electron deficient atom, like here we have got H positive, to become stable. So such a sharing or such a bonding is referred as coordinate bonding. So we can call this bond as a coordinate bond. So for a purpose of definition, we can say that type of bonding in which a pair of electron belonging to electron efficient atom, when it is shared to an electron deficient atom to become stable, then that type of bond will be called as coordinate bond. So we can define the coordinate bonding as the type of bond in which lone pair belonging to an electron efficient atom, means whose octet is complete, is shared to an atom which has got deficiency of electron to complete the octet, and that type of bonding will be called as coordinate bonding. Let's take another example. We have taken NH3. Again, nitrogen will have a pair of electron in its valence shell which will be unbonded, unshared, and these 2 electrons or the pair of electrons will be referred as lone pair. Here in NH3, the octet of nitrogen is complete, so it's an electron efficient atom. Now if we consider another species or a molecule like BF3, then let's check out the bonding in BF3. Here we have got boron and fluorine. Boron has an atomic number of 5, whereas fluorine has got an atomic number of 9. Now if we write the configuration of boron, then it is 1s2, 2s2 and 2p2. Here the valence shell configuration of boron is 2s2, 2p1. Now for fluorine, the configuration will be 1s2, 2s2 and 2p5, that is the valence shell configuration of fluorine will be 2s2, 2p5. Means for the purpose of completing the octet, boron requires 5 electrons. Here we are finding that its valence shell 2s2, 2p2 has got 2 plus 1, 3 electron, Octet means 8 electrons, so it requires 5 more electrons to complete the octet. Now in case of fluorine, we are finding that the valence shell, that is the 2s and 2p orbitals, they have got 2 plus 5, 7 electrons. That means it will require 1 electron to complete the octet. Now let's check out its Lewis structure. We have got boron, fluorine, we have got 3 fluorine in BF3. So now in the valence shell of boron, we have got total 3 electrons. So 1, 2 and 3. Whereas in the valence shell of fluorine, we have got 7 electrons. So for octet completion, firstly, fluorine will share one of the electron of boron. Now its octet is complete. Similarly, this fluorine, for the purpose of octet completion, will share one of the electron of boron, and again here this fluorine too will have sharing of 1 electron from boron to complete the octet. Now here we shall be having covalent bonding, and as we know that in case of covalent bonding, mutual sharing of electron take place. Mutual sharing means if fluorine is sharing 1 electron of boron, means boron too will share 1 electron of fluorine. So here we can see that boron will share 1 electron from this fluorine. This will be the type of sharing of electrons by boron atom. Now after such a sharing, we are observing that the octet of fluorine in all the 3 cases are getting completed, because fluorine was having 7 electron, 1 electron it is sharing from boron. So in all the 3 cases, fluorine will have 8 electrons. But boron was having only 3 electrons in its valence shell. It is undergoing sharing of 3 electrons from 3 fluorine atom. So total boron has got 6 electrons. So in BF3, the octet of fluorine is complete, but that of boron is incomplete. That means only boron has got 6 electrons in its valence shell. So after bonding with 3 fluorine atoms, boron has got total 6 electrons. Means to complete the octet, it requires 2 electrons more, means a lone pair. Now if we observe, then we found that in NS3, it was having a pair of electron which was unshared, and that was a lone pair. In BF3, the octet of boron is incomplete octet. So when these two will approach for bonding, what we find that pair of electrons belonging to nitrogen will be shared by boron from BF3 to complete the octet. Now we have discussed that boron was having 6 electrons in its valence shell after bonding with fluorine atoms. Now when it shares lone pair or the pair of electron from nitrogen, then 6 plus 2, it will have 8 electrons. Means this how its octet is complete. So remember that whenever an electron efficient atom having lone pair shares its pair of electron, that is lone pair, to an atom belonging to a molecule where it has got incomplete octet or where it is electron deficient, then in that case the resultant bond will be called as coordinate bond. Now student, remember, we represent the coordinate bond by a arrow, where the donor atom will have the tail and the acceptor atom will have a head. So for coordinate bonding, we have to represent the bond by an arrow, and the tail of the arrow should be towards the donor atom. Here nitrogen is donating its pair of electron, unshared lone pair, to boron atom. So it's the donor atom. So the tail of the arrow should be pointing nitrogen, and since boron is an acceptor atom here due to its incomplete octet, so the head of the arrow will be pointing towards boron. Now let's come to the mechanism of coordinate bonding. Here again, I would like to repeat, we have discussed in case of ionic bonding that the word mechanism refers to the various steps involved during a process. So whenever we have got a coordinate bond between two atoms, how does it take place, or what are the processes involved, that we have to see in case of mechanism of coordinate bonding. So let's consider the very first example which we have discussed, that was of NS3 and H positive. Here the lone pair of nitrogen belongs to the 2s orbital. Nitrogen has an atomic number 7, configuration 1s2, 2s2, 2p3. 2s2, 2p3 is its valence shell, where 2s has got a pair of electron, 2p has got 3 unpaired electrons. Now we have discussed that the 3 unpaired electrons belonging to the valence shell of nitrogen atom will undergo covalent bonding with these 3 hydrogen atoms. Means these 2 electrons or the pair of electron will be referred as lone pair, which will further undergo coordinate bonding with H positive. Now for hydrogen we know that it has got an atomic number of 1, so its configuration will be 1s1, means its 1s orbital will have 1 electron. But here we are discussing about H positive. H positive means it has lost out one of the electron, means it has got a configuration of 1s0, means 1s orbital will have no electron. Now when H positive approaches NS3 for getting stabilized, what we observe that firstly the paired electron from the 2s orbital of nitrogen moves to the vacant 1s orbital of H positive. Means the very first step. So in the very first step, nitrogen will shift one of its 2s paired electrons to the vacant 1s orbital of H positive. So in the next step, we find that the valence shell configuration of nitrogen becomes, so this is the configuration. One of the electron from the 2s orbital has been shifted to the vacant 1s orbital of H positive. Now already we have observed that these 3 electrons have been participated in the bonding with 3 H atom in NH3. So further 2s and 1s will undergo covalent bonding with each other. So what did we find? That during the coordinate bonding between NH3 and H positive, firstly there was transfer of one electron from the 2s orbital of nitrogen to 1s orbital of H positive. So here nitrogen is undergoing the loss of electron, so it will have a unit positive charge, and hydrogen is undergoing the gain of one electron, so it will have a unit negative charge. Now after unpairing of electrons, we found that these two underwent covalent bonding. That means here we are observing that in case of coordinate bonding, ionic as well as covalent bonding both are taking place. Now ionic bond is represented by charge, whereas covalent bond is represented by a bond which is equal to the number of electrons mutually shared. Here we have got mutual sharing of one electron by both nitrogen and H positive, so we'll be having one covalent bond. And since nitrogen is undergoing the loss of one electron, so it will have a unit positive charge, and hydrogen is undergoing the gain of one electron, so it will have a unit negative charge. So the same molecule can be represented as NH3 single bond H. Now N will have a single positive charge, and here plus and minus, it will have no charge. So here we are observing that during coordinate bonding we have also covalent bonding, and this is the reason why we call such a bond as a special type of covalent bond. Beside this, we are finding that beside covalent bonding, we have also ionic bonding, where nitrogen is undergoing the loss of electron and H is undergoing the gain of electron. So we have to call such a bond as dative linkage bond. So in coordinate bonding, we will be having two type of nature. Firstly, there will be loss of electron from the electron efficient atom to electron deficient atom, leading to ionic bonding. And second, after unpairing of electrons, they will undergo mutual sharing, that is, they will undergo covalent bonding, and hence we can represent the same coordinate bond in this way. For covalent bonding, we are using a line, and for ionic bonding, we are using charge, where loss of electron is being represented by positive sign and gain of electron by negative sign.